Hey class, how's it going? We are going to be finishing up 16.5 today, the last lesson in chapter 16. Just a quick fun fact before we get started. John Wilder Tukey was an American statistician who introduced the box and whisker plot and stem and leaf plots as a way to display data. He used the box and whisker plot to show the 5-number summary of a data set. He is also considered by some to have invented the word software. So quick little fun fact before we get started in 16.5. Today we are going to be finishing up displaying and analyzing data, and our focus, our learning target today is box and whisker plots. If you take a look at the top of page 1124, it says there is a special type of graph that displays the variation in a data set. A box and whisker plot, or sometimes just called a box plot, is a graph that displays the data using the 5-number summary. If you remember, that was our focus yesterday during math class. If you take a look at the example box in the middle of the page, it says recall that the 5-number summary again consists of the minimum value in a data set, Q1, the median, Q3, and then the maximum value in the set of data. What I would like you to do to get started today is answer letter A through letter E over on page 1125. Those are just going to basically ask you questions about the breakdown of what a box and whisker plot looks like. So take a couple of minutes to do that with your group members. If we first look at the bottom of page 1124, letter A asks, how is the median represented in the box and whisker plot? You can see that the median is represented by a vertical line segment that is above the value of the median on the number line. If we take a look at answers B through E on page 1125, letter B says, how are the quartiles represented in the box and whisker plot? The quartiles are represented again much like the median by vertical line segments, but this time you're going to see those above the values of Q1 and Q3 on the number line. Letter C describe the box in the plot. The box is a rectangle with the line segments for the quartiles as 2 of its sides and the line segment for the median inside the box. Letter D, how are the minimum and maximum values represented? They are represented by dots above the values on the number line. The dots are as high as the center of the sides of the box. And finally, for letter E, describe the whiskers in the box and whisker plot. The whiskers connect the dots for the minimum and maximum values to the middle of the sides of the box. So hopefully you are kind of referring back to the previous page, and as you go over these answers, you take a look at the nice visual that the example box has for how they display everything in a box and whisker plot. Alright, let's take a look at the page of top of page 1126. What I would like you to do is take a look at number 2. We want to use that box and whisker plot now after we really broke down and got an understanding of the parts of it to answer each question that is shown. Start off with letter A, identify the values of the 5-number summary for the points scored on the math test, then explain what those values tell you about the scores on the test. Start off with letter A. If we take a look at the answers to letter A, the minimum would be 15, and that means that the lowest grade on the test was 15 points then. Q1 is 40. That's going to tell us that 25% of the students scored below 40 points and 75% of the students scored above 40. The median would be 55. That tells us that half the students scored below 55 and half scored above 55. Q3 is 70. That means that 75% of the students scored below 70 points and 25% of the students scored above 70 points. And finally, the maximum of the box and whisker plot is 90, and that was the highest score on the test. Go ahead and finish up B through E then on page 1126. If we take a look at the answers to B through E, the range for the test scores is going to be 75 points. We take 90 minus 15. For letter C, the IQR for the test scores is going to be 30 points, 70 minus 40. Remember, that's Q3 minus Q1. The explanation for what the IQR represents then is that the middle 50% of the scores had a range of 30 points in between, again, Q1 and Q3. What percent of test scores are between Q1 and Q3? That would be 50% for letter D. And for letter E, you cannot determine how many students took the test because a box plot is only going to show you how the test scores are spread out. Remember, this is another measure of variability as far as how the data is spread out. Take a look at the top of page 1127 and go ahead and answer letter F and letter G with your group members. Alright, if you take a look at the answers to letter F and letter G, Karen is not correct. When you're looking at the median is the middle of the data values, not the number line values. So whenever you're obviously going to determine the median, it's determined on data values, not the numbers that are on the number line. For letter G, again, hopefully you disagreed with Jamal. Both whiskers in the box plot are representing 25% of the scores. So that's telling me that the same number of students scored between 15 and 40 as those who scored between 70 and 90. It has nothing to do with the length of the whiskers. That's probably where Jamal was confused. So keep that in mind when you answer questions like that about box plots. If you take a look at the middle of page 1127, it says you can describe the distribution of a box plot in the same way we describe the shapes of stem and leaf plots or histograms. Take a look at number 3. It says, how would you describe the distribution of the box plot and why? In order to answer number 3, what you want to do is take a look at the whiskers and how they are spread out from the right side and the left side to the median. In this case, the distribution of the box plot would be symmetric because the spread from the beginning of the left whisker to the median is about the same as from the median to the end of the right whisker. If you take a look at the bottom of page 1127, now you are going to be responsible for creating your own box and whisker plot. What I would like you to do is create a box and whisker plot to represent the data about the amount of time students spend exercising at Sharp Middle School. You're going to have to refer back to page 1110 and 1111 in order to get the data that you're going to need to make your box and whisker plot. What I want you to do is, if you turn to page 1128, it's going to walk you through the steps as far as how to create it. And then on the bottom of page 1127, then you can put in your answers from the box and whisker plot about the values of the 5-number summary. What I do want you to do is use intervals of 20 for your number line on the next page in order to create your box and whisker plot. So go ahead and do that. If you take a look at the next page, 1128, here are all the steps that you have to follow as far as putting the box and whisker plot together. So once you do that and follow steps A through F, you can go back to the previous page and fill in the values for the 5-number summary based off the box and whisker plot. Alright, let's take a look at the box and whisker plot that you created then for number 5, just kind of going through steps A through F. Label the number line to include the maximum and minimum values of the data set. So there's your minimum, there's your maximum. That's where you would place the dots above the values on the number line. Represent the median and quartile values. So here is your median right here, that's 40, Q1 was 20, Q3 was 60. Again, those are represented by vertical lines on the box and whisker plot. Then we just drew a line to connect the dots to the box part of the box and whisker plot. Those are considered your whiskers. Just draw the long line right here and then the other short line right here. We name the box and whisker plot. We always have to make sure we give things a title. In this case, it's the time spent exercising each weekday. And then we also want to make sure that we label the number line, much like it said in letter A, and that in this case is the number of minutes. Letter F asks us to describe the distribution. This would be skewed right, since the upper or right half of the data is much more spread out than the lower half or the left side of the data in the box and whisker plot. Now go ahead and refer back to the last page and put in the values for your 5-number summary. Your minimum value was 0, Q1 was 20, the median or Q2 was 40, Q3 is 60, and your maximum value was 300. Go ahead and answer number 7, letter A and B. It asks you to re-examine the original time spent exercising, the exercising data shown. So go ahead and answer letter A, how many values are below Q1 and above Q3, and letter B, why is the right whisker so much longer than the left? If you take a look at letter A, there are 3 values below Q1 and 3 values above Q3. But if you look at that right whisker and why it's so much longer than the left whisker, it's because the data between Q3 and the maximum value are much more spread out than the values are between the minimum value and Q1. So again, doesn't really have anything to do with the length of the whiskers. You have to make sure that you're focusing on that Q3 and that maximum value in this case. Take a look at the top of page 1129. Go ahead and summarize what you can about the exercise data by examining the box plot. If you take a look at some of the points that you could come up with as far as summarizing, 75% of the students exercise 60 or fewer minutes per day. Half of the students exercise less than 40 minutes per day. There is at least one student who does not exercise at all. That's not very good. And one student who claims to exercise 5 hours per day. Yeah, right. Speaking of that, yeah, right, Kai, boy or girl it could be, a value that is far away from the other values in a data set is sometimes called an outlier. We talked a little bit about this word before. An outlier is a number in a data set that is significantly lesser or greater than the other numbers. So if you take a look at number 9, do you think any of the values from the exercise data could be outliers? The likely outlier in this case would be the person who said 300 for the number of minutes that they exercise daily. To finish up on the bottom of page 1129, it says one method for determining if a value is an outlier is to determine if the value is more than 1.5 times the interquartile range away from the quartiles. If a value is greater than Q3 plus the quantity of 1.5 times the IQR, or less than Q1 minus 1.5 times the IQR, then the value is an outlier. So for number 10, what I would like you to do is determine if the exercise data set has any outliers using the formula, and then go ahead and explain your reasoning. Okay, the first thing you want to do for number 10 is determine the IQR of the data set. 60 minus 20 is going to give you 40. Then you can use the formula to determine if there are any outliers. You're going to take 1.5, you're going to multiply that by 40 to get 60. So any value that is greater than Q3 plus 60 or less than Q1 minus 60 will be an outlier that we are looking for. In this case, Q3 was 60, so 60 plus 60 is 120. Any values greater than 120 is going to be an outlier. So 300 is an outlier in this data set. In the other example, Q1 is 20, so 20 minus 60 is going to give you negative 40. Any values less than negative 40 would be an outlier. In this case, there are no such values, so 300 is the only outlier in this data set. What I would like you to do for homework is on page 1130, do problem number 2, all of it. either by yourself or with your group members. That's it for box and whisker plots. Please let me know if you have any questions. Thanks.